Hi.
It's also, oh, yep,
Sorry. I guess I would like to go a little bit more over like how to write a function, mostly because
sure.
I wasn't too much in class. I had to skip a few days, and I also like
Yeah,
2D
absolutely.
arrays. Thank you.
Yeah, of course. Just open up my code editor real quick for this. Just gonna open up a folder. Let's see, courses, learning commons as a students. Sessions. I'm gonna share my screen. Let me know if you guys can see my VS Code.
You're all good. Yep.
Excuse me. Nice. All right, let me just move out.
And if you have any questions, by the way, and you don't want to unmute yourself, you could also post it in the chat. We'll be here
Yeah.
to answer any questions.
Yeah, by the way, I won't be able to actually see the chat. There's already enough on my screen right now, so if anything, just read it out to me.
Don't worry, I got it under control.
Or Capty, yeah. I just renamed this real quick so it's not just all right. So the first thing to do is always get your boilerplate out in C++. We love that. Just ignore the sounds that are coming out of VS Code. All right, so the first thing we're going to be going over are functions. So, well, this over here is a function, right? So int main returns 0, right? So here we're taking in no parameters and returning 0. And its return type is integer, right? I'm not sure if you guys have gotten over the main function is, but it's supposed to serve as some validity check, right? So if it returns 0, that means your program returned safely. -1 means returned with some interruption or something. All right. But there's different types of functions we're able to write, and it's relative to your someone's in waiting room. I'll admit them.
Don't worry, I got that under control.
Yeah.
You just continue.
Sure. Yeah. So functions can have different return types, and the way you specify return types, right, is by using the data type in front of whatever your function is, right? So you have int, you have double, you have bool, you have float, which we don't really use much, but I'm still going to include it. We have char, and we have so these are the main data types we're going to be using. I'm just going to omit float for now, since I'm sure we're familiar with these, right? So these are just your integers. These are your double, let's say your decimal values. More precisely, they're your floating point numbers with 64 bits, but and floats are just 32 bits. But you know, those details aren't really necessary for this class. Booleans are it's best described as true/false values, right? So Booleans are interesting because you don't need to just use true or false. You can use integers for them using 1 or 0. It's just a fact. And then chars are your characters. You have alphanumeric characters and everything else on the keyboard. That's supported by C++. It's relative to whatever Unicode text you have. Or yeah. So your characters and then strings are your words, right? So actually, I'm going to write this. So here in double parentheses is how strings are defined. And then in double quotations. And then in single quotations, you have your characters. So it's like this. And it could be basically anything
That's
you have
fine.
on your, yeah. Sorry? Yeah, so these are your
No, what is going on?
I want my computer. Yeah, I know what.
So let's just write an example of a function. So let's write a function that computes the average. So could somebody tell me which return type I would use for this? So if I'm taking the average between two numbers, would I return a Boolean, double, an integer, char, string? Well, let me be more specific. Let's compute the average of two decimal values. So in this case, I'll be returning a double. Right? So you're computing an average. You're going to be computing the sum of two doubles, or in this case, two decimal values, and dividing by two. So division by two will result in integer or decimal, but in this case, it's better just to use a double. You know, averages are decimal values most of the time. All right, so we'll call this mean, right? So double A and the double B, right? So here we have the return type you want. It's the double, the name of the function. So this can be whatever you want it to be. I can name it my name if I wanted. It can be all capitalized. The thing is, you can't have separations of this, right? Because typically separations would mean that you have another keyword. As you can see, Kev is not a keyword. I don't know. It's highlighted green right now. So it could be a keyword for something else, I guess, for this code. And then for as you can see, AW has a squiggly line underneath, so it's not valid. So in your case, you're not going to be using any other keywords aside from just the list of return type. You might have other cases where it's a const, for example, or static. Typically that would go before the return type here. But in this case, you're just only concerned for the return type and then just the name of the function. In this case, it's mean. Okay. And what follows inside these parentheses is we have two values. We have double A and double B, right? So you have to specify what the parameters are, right? By using a data type, right? So in this case, our data type is a double, and we call it A, right? So that's just the R value, right? The reference for this, that is double. And then on the right-hand side here, we have it's separated by the comma, and we just have another double value. So those are your parameters. Okay, and inside your function, you have your code. So we're just computing the mean, right? So I'll just return A plus B, and I'll put these in parentheses to ensure that the order of operations is being executed. And here we go, right? So A plus B divided by 2 gives me the mean. All right, so let's test this in the main function. So to use functions inside your main function, you just simply have to call the name of your function, right? There's a bit of nuances here. So first, let's actually get our double values. So let's call this A, and I'll say this is 4, B equals 6, right? Let's actually get ourselves the decimal values. So I'll do 9.4 and then 4.4. Right? Okay. And what I could do is I can compute the average by just simply calling the function, just writing its name, and then putting in the parameters. For in this case, in this context, we're calling these arguments, right? So the arguments are what you're actually putting in, right? So your A and B, and the parameters is just another word for what you expect to put in, right? So A and B are your arguments. Now the arguments don't necessarily just need to be A and B, or rather references, but instead what they can be are just double values, right? So I could put 3.4 in here and then 4.5 if I wanted to. And I mentioned there's a nuance. So here I'm able to execute this as normal. However, I won't be able to see it on the screen, right? And there isn't going to be any error. It's just it's gonna run normally. So let's actually do this. Let's get the screen a little bigger. See, we compile this. I run this. As you can see, nothing happens in the terminal. Zoom this. All right. So if I want to actually see what the output is, I can do two things. I can either assign it to some other double value, right? Because mean returns a double, or I can just print it out by using the C. So now if I run this, As you can see now, it prints out 3.95, and that's the mean of these two numbers right here, 3.4 and 4.5. And if I wanted to print out what C is, I would just simply and as you can see, you get the decimal values. Are there any questions on this? Okay. Now let's try to implement arrays into this. Right? Let's say I wanted to write the following. Let's say I wanted to write a function that computes the average grade, right? From a list, from a class of 10, right? So what I could do, right, is I can go and try to write something like this, right? I do double grade 1, say someone gets 100, and I keep doing this, right? But the problem with this is I'm not going to want to write that many grades, right? Or that many double values. I want a way to contain everything. So this is where arrays come into play. So I'm just going to erase all of this. I'm going to keep the function. But we're not going to be needing it, right? Because we're only computing the average of two numbers here. What if I want to compute the average of things in a list, right? Or more precisely, an array. So let's talk about arrays. So let's just write this array, the one I want. So double int 10, and then, oh, sorry. Let's call it double class grades. And okay. So what this is here I define the data type I want, right? As usual for basically any other variable that I've had before, except now the name here, right? Class grades is followed by this funny looking thing here, right? So brackets 10, right? means that there are 10 slots. Structure, data structure. Okay. More precisely, there are 10 indices available. Okay. What that means is I have a container, right, where I have 10 shelves, right? You can imagine it's like some sort of like bookshelf, and I have 10 slots available within that shelf, right? And each one has a index starting from 0. But it doesn't end on 10, instead it ends at 9, right? So this is something you need to get used to, is that in arrays, or typically in most structures, you're going to be indexing starting from 0. So that just means that your very first value, the address of some value you're going to be putting into this array, starts at 0, it ends at 9, or more precisely, it ends at n-1, where n is the size of your array. And in this case, we define it, right, with, I'll say, data type array, or just ARR for short, n, right? So this is how you define your array, or you initialize your array using language you've learned so far. Okay, so now that we have the structure defined for us, let's start putting things inside, right? So the way we'll put things inside is as follows. So we can do class grades, and I can refer to the index using the same exact notation I had before here, these brackets, and I put a 0 here to denote the beginning, right? So that means class grade 0 is equal to, and I give it a grade for that, right? So I'll say 97. So this is a very good student. And then here I have class grades of, let's say, 1, right? So the next student, and this student did not study at all, right? 32. Okay. So now you may be wondering, well, if these slots have numbers associated to them, what about everything else, right? Well, it depends on what data type you're using. Like, for example, since we're using double values here, everything by default will be initialized to 0, right? And we can see that. So if I were to iterate across this array, the first two grades should be non-zero. So let's see that. So I'm sure everyone has seen a for loop. We can still cover with how this works. So here I'll iterate from I equals 0 to I less than 10. And I'll just print out everything inside associated to that index. So class grades of I. And I will do this end line here so I can print it out at each line. And I'll say that this is student I plus 1, because I want to begin from 1 and then end at 10. Okay. So let's see if this prints out. Okay. Let's see what happened here. What's going on? Oh, let me actually space here. So I guess it actually. Okay, so here it's not actually 0. It's very close. It's a very, very small value. Let me actually initialize this to integers instead. So, because these are already integers anyway. Oh, interesting. So they're not 0 at all. Oh, okay. I see what's going on. Right.
It could be
So
like just
here-
garbage values, I'm assuming.
Yeah.
Because you
So
didn't
this is not
initialize
safe
them.
what I'm doing. So here I have that I'm only giving values to 0 and 1. I think what I have to do is this correctly. There we go. Yeah. So yeah, I have not been using arrays recently. I've been using more vectors. Much better. Anyway, so with arrays here, we actually specify this is that when you initialize an array, it's important, well, relative to what data type it is. So if it's like a number, numerical based data type, it's best that you initialize it with this notation here. So this is equal curly brace, 0 curly brace, right? So that means you're assigning each value at each slot to 0, which is why if you look down here from 1 to 10, as you can see, it has the first two students and everyone else, I don't know, they dropped the class or just gave up, right? So that's what you have there. So reason I mentioned this is because, as Lauren mentioned, is that if I have nothing initialized to it, thank you, Lauren, by the way, I end up getting garbage, right? And this is not safe. So these are numbers that are huge, very small, or make no sense to what your structure was. Because no students can get this grade. A grade of 1 is possible, but it's very sad. But yeah, so in this case, it would be safe to initialize to 0. So that plays into memory, which is a topic I don't think you guys have covered just yet. But it might have been mentioned in your class. I have not seen your slides. Okay. So always important to do that. So now let's go back to what we were doing. So double class grades 10 equals 0. Okay, great. So a better way of actually initializing it, right, is as you can see here, it's 0, right? So that applies it to every single slot. But what we can do instead is we can initialize individual slots ourselves, right? So let's go and give ourselves values for these, right? So let's go with a grade of 97, a grade of 45, a grade of 87, 90, 67, 34, 100, 67. Let's do 65. So you have 1, 2, 3, 4, 5, 6, 7, 8. Just 2 more grades. 41. And Lauren, give me a grade.
94.
All right. So now let's iterate across this. And let's see what we get. Beautiful. So as you can see, each index, so I'll write it here in the comments right above. So 0, 1, 2, 3, 4. Don't worry about this little dot that's appearing here. That's just my IDE is doing automatically for comments. 7, 8, and 9. So it's index 0 all the way to index 9. And that's what we get, right? But here's the student one because we're just adding one here to, start from one instead. Okay, but now we want to compute the average, right, of these grades. I mean, I could do that by hand, but I could just do the C++ function, right? So let's write a function for that. So I'm going to write it here, double. Actually, before I move on, are there any questions on how the array is initialized or just in general, anything pertaining to the array? Okay. So let's write the function to compute the average. So compute, let's say average class, right? So I can first, excuse me, initialize my, I can provide my parameters. So I'll call this class grades, or I'll just call it array. And I will say the class size, so the size of the class size, and I will return a double. So that's what I have here. Okay. So the first parameter here is just the array. So arrays have dimension. In this case, this is a one-dimensional array because it's a single row. In future examples, we'll cover two-dimensional arrays if we have time. And an int class time, this is just to give us a measure, right, to determine how far we should iterate across the class. Like for example, maybe I only want to take the average of the first 5 students for some reason, right? But generally like to take the average. Okay, so I'm going to initialize something called sum, right? So this is just for just keeping track of the sum across all the grades that I have here, right? All right, and then I'm gonna write my for loop starting from I equals 0 because the indexes start from 0, and I do this until I plus the class size, and I iterate, I increment, right? Okay, so now I do sum plus or equals, right? So what this is saying is I add to the sum and then I initialize it, or I reassign it to that value, right? So this is going to be array of the index. This is going to be I, right? So this line here is just going to compute the sum across all of these values, right? Across the class. So it begins from 0. So it goes 97 plus 45, right? And then it takes the sum of those and does that plus 87, plus 90, plus 67, plus 34, and on and so forth until the end. So that's what we get there. Okay, so once we have the sum of all of the classes, all of the grades within our class, then we would like to take the average. So what we're going to do is simply return the sum and then divide it by the class size, right? Because that's the number of grades that we've added across that list. Okay, and that should return a double. So let's find the average of this class. So I'll just keep this inside. I'm going to comment this out, and I'm going to call, let's say, class average. And this is called average for class. I take in the class grades array, and it's size 10. Okay. And we run this, and we find that the class average is a 72. No bueno. So maybe we can apply a curve. Curve. Actually, no, never mind. I don't want to do that right now. But yeah, I mean, you can also create a function to calculate a curve for the relative to the class average, I guess. All right, so that's the class average function. Are there any questions on that? Okay. Let's do one more thing. This is gonna be quick. And then I'll pass it to Lauren. So maybe we'd like to get a letter grade for this, right? So let's actually write a function to do that. Let's make it simple for ourselves, right? So CUNY first already has a rating system relative to your the numerical grade. but let's make our own up. Right? So let's say a grade between 0 and 0 to we'll say 60 is an F. So in this case, let me do that uninclusive. And I'll include 60 here. And we'll say anything from 60 to a 75 is a passing grade, so a C. Okay. Actually, let's do a 79. Let's do an 80, actually. Yeah. So I could do an 80 to an 80 or, yeah, 89 would be a 90 would be a B. And then anything including a 90 to 100 would be an A. Right. So I want this grading system. Okay. So here I'm going to be returning a character, right? And it's going to be an A, B, or C, or an F. Okay. So what I'm taking in is a double, right? Because it's within a range. So I'm going to call this, let's call it grade conversion. Okay. Double grade. And I'm going to check if it's within a range and then print it out if it falls within that range, right? So the first range we'll check is if it's within the A range, right? So if the grade is greater than or equal to 90 and the grade is less than or equal to 100, right? Then we return the letter A. So our student gets an A. Okay. Else if, right? So we're gonna go down the line. Else if the grade is greater than or equal to 80 and the grade is less than 90, right? Which is why I include these parentheses here. It's not including that number. We return a B. Else if the grade is greater than or equal to 60 and the grade is less than 80, we return C. And else if, well, here what we can do is, well, here we still need to specify because otherwise else could be 1,000 or something else. We don't want that. So we're going to do else if the grade is within the F range, so greater than or equal to 0, and the grade is less than 60. We return an F because they failed. Should have studied. All right. Else -1. So I'm only including -1 as like an invalid number, right? So maybe the grade you got or the grade that was provided was not within any of these ranges at all, right? So that's just a fail safe. Sorry, this should be returned. Oh, sorry, it won't be -1. This is a character. Let's do we'll do, I guess, this symbol here. Why not? I just chose it randomly. So invalid grade. All right, but we're only concerned for these grades here. All right. So now we can put this to the test, right? Let's see what the class average is as a grade within this range. So it should be a C, right? So let's actually give this, let's give a variable this number. So class average equals this. And say class. So we'll say numerical score, numerical average, class average, oops. We'll say corresponding per grade. Okay. And we'll say, what is this called? Grade conversion and class average here. All right, let's see. Numerical average, class average, corresponding. Yeah. All right, and let's run this. So yeah, the numerical average is 72, corresponding letter grade is a C. Great. And let's just do one more example. So let's give our students a very good average, 98. Let's change over for change this to 8, 7. Registration, let's see, averages here. Yeah, the numerical average is a 93.2 and the letter grade's an A. Yeah, and also if we wanted to, we can also go through each individual grade and then give them a letter grade as well. And yeah, and there's many more possibilities you can do with this. So that gives you guys a taste of functions and arrays and also combination. I mentioned two-dimensional arrays, but I'm gonna give Lauren the stage now. So maybe she'll go for it.
Yeah.
Are there any questions on that? Sorry.
Just a question. What is
Yeah.
the 10 inside where it says double class average equals average for a class and then parentheses class grades 10? Oh, in line 57, yeah.
This one right here?
Yeah.
Yeah, so this is the size of the array.
Okay.
Yeah, because otherwise, if I just provided the just the array, there is a way to get the size of it, but the syntax is a little more advanced and often confusing. So in this case, the simplest approach would just be to hard code the size,
Oh,
the
okay.
different parameter. Yeah.
Thank you.
But yeah, but if you're interested, it'll just be I think it's like you get the size. Let's see. Yeah, I forgot the there's a I don't know if Lauren or Kathy remembers. How do you get the size to the array? I know there's like a oh wait, I think it's
Isn't it length?
not length. No, length is for array for vectors. For the fixed like size ones. Yeah. 1 second. Let me just no, I didn't mean to do that. Right.
Size of.
Oh, yeah, size up. I got it. Close everything. Let's go share. Yeah, so if you're, yeah, I think this will show it. I don't like leaving out details. So size of array divided by 4. So the reason I divide it by 4 is relative to the size of your data type. Yeah, actually, let's do the size of double. I think this is it. Let's see. See, warning, error use of unidentified class size return. Oh, right, guess. These are just warnings. It's okay. Let's see. Oh, this still works. Yeah. So yeah, so you can do this. So this basically gets the size of your array by counting the memory size. So the when it comes to memory size, each variable has a given number of bits you can use to represent it. So in this case, if you have a double, I believe it's 8 bytes you have. So that's 64 bits. And then, yeah. And then, so if I do array, right, you're basically counting, first you're deciding how many values you have within that array. In this case, we have 10, right? And then you're multiplying that by 8 in this case, right? So in this case, it'll be 80, right? 80 bytes. And then divide that by the size of a double, which is 8. So divide 80 by 8, right? You get 10. So the resulting value would be 10. So this is another way of doing it. I just omitted it because I don't know if you guys have gone over this, but it's still very useful.
Yeah, I saw it in lab, but I didn't
Oh, okay. That's good.
know. But thank you.
Yeah, but does that make sense?
Yeah,
Great.
thank you.
Yeah, no problem. All right, Lauren, it's all yours.
All right, cool. So I'll go over a little bit more of like 2D arrays. So let me get a compiler up. Yeah. So the example that Kevin went over was more of like 1D array, right? But this time we're going to be doing a 2D array. And the difference between like 1D and a 2D array is when you have a 1D array, it's only going to be one row, right? So like you have something like 1, 2, 3, 4, something like this. But a 2D array is going to be a little bit different. You're going to have different rows. So I might have something that looks more along these lines. I'm just going to do it like this just to show. Right. So we have an example here where we have 3 rows of 4 numbers each, right? And when we write that out, right, this is what it would end up kind of like almost looking kind of like a grid pattern like this, right? But we have like a little bit of a different syntax for that. So what I can do is I can initialize something like that, right? Let's say int array. Wait, am I not? No, I'm sorry, I'm thinking of Java. Wait, Kevin, I'm doing this right, right? I'm sorry, I'm mixed up in my programming languages. Right, so I could do something like
I'm sorry. Are you trying to define an array?
yeah,
Make sure to have the brackets before. If you're making a two-dimensional, make sure to have 2 brackets.
2 sets of brackets like that, right?
Yeah, there you go.
Got it.
And make sure to give a size as well in there for rows and columns. Going from left to right.
Right, within the brackets?
Yeah.
Okay,
Do
gotcha.
like 3 and 2.
Yeah, okay, 3 and 2. Let's just do that then. So this would be 3 rows and 2 columns, right? So
Yeah.
3 rows of 2 entries each. So we have something along these lines, right? 1, 2, 3, 4.
And make sure that the arrays inside have the curly braces.
Oh, so they also need the curly braces? Okay. So if you're declaring it like this, then you are indeed dealing with curly braces, right? To define each one. But in terms of like the actual array syntax, you use the square brackets. So we have ourselves a little array over here, right? Now, Kevin went over an example in which we used a for loop to loop through this, right?
Hmm.
The issue is here, though, if I were to loop through it, we treat each of these as one element, right? So each of these boxes is one element. So that means 1, 2 is one element, 3, 4 is another element, and 5, 6 is a third element. If I have only one for loop looping through it, it's not going to give me my intended results of saying 1, 2, 3, 4, 5, 6. It's going to give me what's called a pointer to this first entry here. And a pointer is just an address. You could think of it as 1, 2 lives inside of this box, right? It's as if it lives inside of an apartment here. And that's not exactly what we're looking for. We want to go inside of the box. So to do that, we're going to have what's called nested for loops, right? You probably have done this before in the sense that you're going to have one loop to loop through your rows. So 1, 2, 3, 4, 5, 6. Those are your 3 rows. And then you're going to have another for loop to loop through your columns, right? And that's going to give you the 1, 2, and then the 3, 4, and then the 5, 6. So I'm going to do that. So for int, we can have r for row. We'll start at 0. R is less than Well, our row is 3, so I'll just use 3 for that. R++. And then I also want to have another one here for our columns. In this one, it's less than 2. Awesome. So now if I were to say something like cout our array, and I want to go through each index, right? To get the exact point that I'm looking for, right? I can use two sets of square brackets. I could use a set of 2 square brackets like this, and I can do array at position R, position C. So it's almost like a coordinate plane in a sense. And this is going to give me essentially my row and my column, kind of like the address of where I'm going. So if R is 0 and C is 0, that's going to give me 1. Then if C increments to 1, that's R is 0, C is 1, that gives me 2. Then at that point, right, we're finished with this box. So R will increment by 1. So this becomes 1 and 0, that's 3, 1 and 1, that's 4, etc., etc. If I were to run this, right? Look at that, it prints them all out on a different line. Now, what if I wanted to kind of go more based on the way that this is formatted, right? I want to actually have it in the sense of a row, right? Well, what I can do in that case, right? Just going to add a little space here just to make it a little easier to see. But what I can do is I can actually say after each row finishes, that means after I loop the entirety of both columns, I could put an endl over here. And what this will do is it'll say, okay, for every row that you do, loop through the 2 columns within the row, then make a new line. And just like that, this is showing us exactly what this array looks like. So you can clearly see here, 1, 2 is its own row, then 3, 4, then 5, 6. So this is essentially 2D arrays in a nutshell. Does that make sense to everyone?
Yes, thank you.
Awesome. Okay. So that would be one instance of the 2D array. Now, I wanted to go over something a little bit different with one of the examples that I saw, but we can definitely incorporate 2D arrays into that. So there was an example within the notes that kind of went over like a random number generator, you could say. So what we can do is we can essentially put this into like a function, and instead of having this over here, right, the actual given numbers, we can just kind of have an empty 2D array over here, right? We could just probably initialize that to 0. Oops. So everything gets initialized to 0 here. Just let me double check to make sure. Yeah, okay, we're all good with that. So what I can do now is I'm going to actually create a function that will let me put a bunch of random numbers in these positions. Okay, so let me do I'm going to do a void function up here. Void meaning that it's not going to output anything, right? It'll just like cout the actual array itself. You can have all different types of functions as we did before, but this is an example of a void function. So this won't have any return, but it will actually cout the value within it. So I'm going to call that random number, and this is going to pass in our good friend, the array over here. And since it's a 2D array, I want to pass in the two brackets here to show, yeah, this is, it's a 2D array. And for the capacity, right, we want to say the rows and the columns. I can say rows and columns, and I will need to define these guys, right? Int rows, int columns, and int array over here. So this is going to take in my array. And just like last time when we had the size variable, this time we're going to have two size variables because it's a 2D array. So with that being said, now we want to actually get into looping through this array. So like last time, I'll do the same thing here where I have int r equals 0. R is less than. Well, over here, I'm in what's called a different scope. And the scope is what is enclosed within these curly braces. So this is a different scope than my main. So when I end up calling this function down here, right, random num, and I pass in my array, and I pass in my rows and my columns, right? This is going to go into the scope up here. And if you notice, because it's not within the scope of the main function, it won't know what my rows or my columns are unless I actually pass them through. You could think of it as like a warp pipe that warps this right into here. So my array is up here, my rows are here, and my columns are here. So the array gets passed in here, 3 passes in here, and 2 passes in here. And I could change this to anything I want. If I had another array that had like 5 and 10, I could just pass that in here. That's no problem at all. So that's always something to keep in mind. These don't have to always match in the name. The only thing they have to match in is data type. I can't have a string array here if this is an int array, or vice versa. But I could call this something else. Like I could call this A instead, if I want. I'm just keeping it as ARR just to kind of show like, yeah, this is dealing with the array itself. But if this was different, that would be totally fine. Okay, so going through this again, right? We're going to loop through the rows. And for this, I'm not going to say R is less, I mean, I could say R is less than 3, but with functions, you want to try to make them reusable as possible. So I'm going to say R is less than rows, which this got passed in from the function, which got passed in from here, the main. And R plus plus. And then we have our columns. So for in C is equal to 0. C is less than cols this time, and C++. Awesome. So this is going to, whoops, this is going to loop through our array now. Now, just to show that this actually does work, I'm going to say cout array at position R, position C. And let me just do a little space at the end over here. And just like last time, I'm going to have it formatted nicely. So we'll do the cout endl over here. And you'll see that there is an error. Yikes, what is happening? Kevin, can you just double check this?
Hey, what's up?
Yeah, I'm getting an error for some reason.
Can you scroll up on the terminal? I think I know what it is, but just want to make sure. Let's see. I think you're gonna need to, yeah, you're gonna have to define the bounds for the last array here, for the last container. So for columns, like put columns for into array. Like the second dimension, specify that. Yeah. If not, just hard code it. Just put the number. Try again. Oh yeah, so it's not declared in scope, so put the actual number then. So if that's the case, then you're gonna need to,
Okay.
yeah, there you go. Were you expecting zeros?
Yeah, that's fine.
Okay, gotcha.
No, because like I had them appear
Yeah.
the bounds.
So before it just wasn't defined in the scope, and yeah, and before that, you need to actually specify the dimensions. It's fixed size.
Okay, so
Yeah.
yeah. So for this, the second one just has to be defined then in that case. Okay.
The innermost dimensions.
All right. And I can't necessarily
That
just
includes
pass this
every,
in though?
like if you have 3 dimensions, you also have to specify the columns. It's the rows and the columns.
Yeah, but I can't just pass this in.
No,
Over here.
it's, if you're passing columns, there is not defined in the scope. Because
Okay.
the compiler doesn't know what columns are until it sees them. Actually, try this. Try putting into columns first. Before. Okay. And then
Let me
later
just
put
switch
columns.
the order
And then put
here.
no put columns instead.
What?
And then
Oh.
put columns. Yeah.
Okay.
And then try running.
Wait, did you have to switch the order here though?
Oh yeah.
Yeah. All right. No.
Right, that didn't work. It's okay. Just revert it to what it was. You don't have to move column the array. Just change columns to 3.
Whatever. Okay, so in conclusion, you kind of just need to make sure that this last innermost term is always defined then. Otherwise, you're going to get error there. Okay, well, now that that works, let's get to what we were going to actually do in the sense of actually generating some random numbers. So when we're doing random numbers, right, there's like a little formula that we want to keep in mind for this. Right? And this you probably have gone over a little bit in your class in the sense of kind of finding a way to generate a random number. So for this, right, we want to use the following formula. Random, we're going to mod that by high minus low plus 1. These are going to be our bounds for the number, plus low again. So this is essentially equal to the number of values that are within your range, right? So if I wanted to get like a random number between 1 and 10, let's say, I'd call the random number function, right? Anytime that you see something like this with the brackets, that's just saying like you call the function mod high. Well, the highest number in this range is 10, minus the lowest number is 1, plus 1, right? Because we want to make sure that like it ends up going back to that original number, and then plus the low value again, which is plus 1. So that's how we would get a random number between 1 to 10. And this could work for any number too. If I said like 1 in 1,000, or if I did like 200 and 500 or something, it's the same thing. You just want to know your high bound and your low bound and plug it into this formula here. So what we're going to do is here, we're going to essentially have a generation of these random numbers. So what I'm going to do is in every instance, I'm going to say array at position R position C is going to be set equal to this right here. So I'm going to call the random number function, and it's going to set a random number between 1 and 10 into that position, and then it's just going to output it. So before we do that, this is going to be called from the random number library. So to do that, we're going to just need to import a few things over here. So you know how we have include IO stream? This is a library that we import that allows us to have input output stream. for doing a random number, we're going to have to import this library, CSTDLIB. Right? There's one other thing we have to import, but I'm going to show you exactly why we have to do that. So this is going to allow us to use the random number function. Okay. Now you see these first zeros are just from this original one we did. So if that's the case, let me just comment this out. That way, we just get what we want to have outputted. Okay. Awesome. Right here. Right. Okay. So if you notice though, every time I run this, the numbers are exactly the same. This is because we didn't reset the seed. So if you ever played like Minecraft or like a game that has like a random generator to it, you have what's called a seed that kind of makes random numbers kind of predictable. So every time that this essentially compiles, right, it's going to generate these random numbers and it's going to stay at the current seed. So that's why every time I run this, it's going to be the same thing. So this is kind of what we call pseudo-random. To switch this though, it's actually really easy. So we just need to put in 2 extra lines of code. We want to include a new library called ctime, and we want to initialize time to 0. So what we can do is, I think I could do this over here. srand calls the srand library time 0. And this just resets it. So when this runs, actually probably it would be best to do this in the main function. So as soon as the main function is called, right, which we know the main function is the first thing that's called, it's going to reset our seed. Then it calls everything else here. Okay, we don't really care about this right now. All we care about is the function call, which I'm going to move this up a little bit over here. So you could ignore the part that we did down there. So every time that this is called, it's going to reset our seed. And because of that, there's also an error. Oh, great. Oh, oops, that was just because I moved that. Yeah, so the order of things is very important. I have to make sure that when I call it, it's after when it was initialized. Okay. Here we go. All right, so if you notice, now the numbers are different. And if you notice, every time that I run it, it's going to be different. This is because every time it's being ran, this srand times 0 resets my seed. And then it calls my function. So every time that I get a random number, right, srand, it resets that. So I'm going to get a different set of random numbers each time, and each of these random numbers is generated within my 2D array. So that is pretty much random numbers in a nutshell. And there is one last thing that I wanted to do about this. And that's the difference between passing by reference and passing by value. So you might have heard this before, and if you noticed in this problem, right, I had a void function, and the reason I did that was because I'm just outputting things, right? I'm just setting something here and outputting it here. Okay, well, what about if I was saying, okay, well, I want this here, right? I want to output it here, but what if I wanted to, instead of outputting it here, output it here instead, right? So I'm gonna actually uncomment these guys over here. And if I were to run this again, right, we expect that it will clone this, right? In the sense that this comes after I run the random number generator. And you're right, that would happen. Arrays have a special characteristic to them in that they're always what we call pass by reference. If you notice here, we pass in the reference of our array. because this is, as I said before, arrays are just a bunch of addresses, pointers, right? In an array, there are a bunch of values, and they're all kind of mapped to each other. It's as if you have a bunch of people living in an apartment house. You're going to have pointers or addresses to each of their apartments. So that's great if you want to change those numbers. But if I just wanted to generate a separate random number array and I wanted to like not have it save, then that might be a bit of an issue. I'm going to show you an example in which that's not the case, that it doesn't save. So if let's say I had down here, I don't know, let's just say I had int x, which is equal to 5. And I'm going to create a function called change x. And then I'm going to call cout x again. Okay, so let me say cout x before. And over here, I'm going to cout x after. Okay, cool. So of course now I need to actually define the function, and what I'm going to do is I'm going to do this right under here. So I'm going to call this change x, and that's going to pass in int x. And my return type for this is, you know what? I'm going to also have this as a void. And the reason for this is because, actually, you know what? I'm just gonna have it in text. That's fine. Turn x plus 5. Okay. So this time, instead of having it as a void, I have this set as an int, right? So this means I actually do have a return type. It's going to be an integer. And the reason for this is because x is an int, and we add 5 to it. Boom, still an int. But what I'm going to do here is I'm also going to say x is equal to x plus 5. Actually, yeah. Okay. So what this is going to do is it's going to actually change the value of x over here. And it's also going to return that value as well. So going back down here, right? We set x equal to 5. And when I cout x before I do this function, right? It's going to just say, okay, x before is 5. That's the original value of it. I'm going to call change x and pass in my x variable, right? We know that I'm going to also return a value. So let me cout value there. And then I'm going to also cout after I exit this function. So this is like before, during the function, and after. So let's see what happens. Okay. So, oops, I should probably do an indel. That way it's a little bit easier to see. All right, cool. So first things first, we have x before is 5. During the function, it becomes 15. And I need to stop accidentally going back. Okay. And the reason for this that it goes to 15 is because we changed the value of x, right? Over here. And then we return x plus 5. So x starts as 5, plus 5 is 10, and then we return 15 in this case, right? I could even simplify that further, but that's honestly fine. What happens here is it changes. But then if you notice, x after is still 5. Seems a little weird, huh? This is because x has been passed by value, not by reference. So there's a copy of x, copy of this 5 that gets passed in. So this value, this function here is still going to change, like it's still gonna do what it's supposed to. I mean, it's telling you, okay, add 5 to x and return x plus 5. Or even if I would just say return x, right? Keep it simple, right? Right? It's just gonna add 5 and return that. Right? Pretty simple. But it doesn't say to keep that value because the address of x is not being passed in here. When we had the array, the address of this array had to be passed in because you need to know the pointer of this array. You need to know its address because every entry in here is a certain number of bits apart. You want to know how you can travel between these guys, between all these different addresses. Here, though, all I care about is just some value that gets passed through. As long as it's an integer, I can do this with it, and I just return it. That's fine. Once it exits the scope, these changes are lost. We need a way to save these changes, and this is where pass by reference comes into play. And this is a very simple change. It involves adding an ampersand, like the little and symbol, above my variable right here. And you're going to see that instead of this being 5, my changes are going to be saved because this is saying pass in the address of x. This exact instance of x will be passed through, saved to that address, and returned out. So you're going to see it's been saved. So in this case right here, when we change the value and returned it, right? It's returned here and it's been saved. Now also something interesting is I directly changed the value of x here and I returned it here. Before I had this, right? Return x plus 5. So I said change it and then return a different value. This is going to result in something a little different, which goes on to the differences between assigning and returning, right? Every function returns something unless it's void. During the function, I changed the value of x, right? This is where x became 10. This is the value that got saved. But returning is just what this function is going to return. So this is saying do something with that x and put it right here. This return type of 15 will go right here. And that's it. All that's going to be is there. Now I can assign this to some other variable. If I really wanted to, I could actually say that x is equal to change x. And this would actually have gotten it to save. Or actually, well, that makes it add another one because I called it again, right? There you go. That brought back the 15. But the point of this was that because I called this by reference, I put the ampersand there, I put the address here. Any changes that I do to this x are saved. So that means any assignments that I have, which are done here, right? Anything x is equal to something, gets saved. Return values, the only thing a return value does is it takes this and it stays in wherever I call the function. So this is saying I'm calling the function and I just want to see out it. It stays at that point and then it's gone. If I used this over here, I'm setting x equal to that. That value is placed into x. It's placed into that box. And once again, if I were to remove that ampersand, we go back to the original problem, right? That x is not saved. If I did something like this, I could get it to save. Right? This is a way around that whole issue, right? I set it equal to the variable itself here. And this actually got it to save. So during this function, it didn't save the value. It just said, okay, output it, and then I'm done with it. Dispose of the value. I called the function again. I set that equal to x. And now anytime that I call it after, that value is saved. So two ways of saving it. I could save it like I normally do with just setting it equal, or I use the ampersand before my variable in my function. Right? And this time it gets called twice. It gets saved here, and that value gets put here, which gets put here. So that's why this became a little bit larger. But that just kind of combined a little bit of everything. So yeah, that's kind of just a little bit of everything when it comes to 2D arrays, functions, pass by reference, pass by value. So at this point, if anyone has any questions, otherwise I'll pass it back to Kevin.
Hey, great
I
job.
sorry. I do have a guess similar question that was asked in a quiz, and it's like kind of similar where like the value of the variable changes. Uh, so it was like, wait, give me 1 second.
Sure, if you want, you could post it in the chat.
Hello, I'm so sorry. I left the meeting accidentally.
You're good, don't worry.
I will try to put the pictures I took, my notes in the chat.
Sure, whatever's easier for you. You could go over whatever it is. Oh, okay, I see.
Okay, so one of them is like an in-class, uh, it's like similar question that we did to the quiz, and I thought I understood it, but then when it was time for the quiz, it just didn't make sense to me anymore.
Okay. Cool. Okay, I'll switch to I'm gonna just stop sharing and then share. Okay. So
Mhm.
over here we have our main function, right?
Mhm.
And for this, right, we have two arrays. We have X and we got Y. So this is saying C out Y at position 3 mod 7.
Mhm.
So Y at position 3, this is 0, 1, 2, 3. That's 7. We take this, mod it by 7, and 7 divided by 7 has a remainder of 0, so that prints 0.
Yeah.
Okay, then this next part here is saying C out Y at position X at position 1. So let's work from the inside out. Over here, X at position 1, 0, 1. This is 3. So this just becomes Y at position 3, 0, 1, 2, 3. This is 7. Now this is where we call our function f, right? Are you good with these 2 parts, by the way?
Yeah, I am. Sorry.
Okay. Yeah, no problem. So we're going to see out our function, plugging in parameters x at position 0 and y at position 0. So we can see up here that function f takes in an int x and an int y. This one getting passed in by reference, right? It has that little ampersand. So x at position 0 is 4, and y at position 0 is 2. So we're going to do this function, right? X is equal to x plus 1. So that means x is going to go from 4 to 5. Y is equal to x minus 1. Okay, well, y is equal to, it goes from being to 2 to x minus 1. Well, what is x? 5 minus 1 is 4. The key here is that y is being called by reference, but x is not. This guy over here is going to get saved. This one is not going to get saved when this function ends. So return x plus y, we're going to be returning 5 plus 4. And that's just going to be 9. So what's going to get outputted here is 9. But the most important thing is that for any other questions, I don't see any more here, but let's say it was going to output C out. Let's say it was going to C out X at position 0, and then X at position, Y at position 0, right?
Mhm.
The X was not changed permanently because it did not have the ampersand, meaning that we go with the original value. This part is going to just be 4. The Y, on the other hand, right? This had the ampersand. We changed that to a 4, meaning that this will get permanently changed to a 4 as well. So when we output it in the next line after that, it's going to be a 4, not a 2. Does that make sense?
Sorry, can you repeat the Y part again?
Yeah, absolutely. So Y started out as 2, right?
Mm-hmm.
It was a 2 over here, Y at position 0. But we know from the previous function, we passed that in over here, but it had the ampersand, meaning that anything we changed here gets changed permanently for Y.
Okay.
You get how we got 4 as Y
Yeah.
over here. Okay. So because this ampersand happened, that means that this 2, Y at position 0, permanently becomes a 4, because that's the new value of Y.
Oh, okay, I see.
So when we output it, C at X at position 0 stays the same. It's a 4 from the original value. Y at position 0 changed because of that ampersand. That function did something to it, and it became a 4. So that's why that becomes a 4.
Okay. Now that makes more sense for the quiz I had.
Awesome.
Okay. Thank you so much.
Yeah, Yeah, no problem. And was there another part that you wanted to go over here?
Yeah, it was the quiz. But I see that it had the and percent, and that's the reason why uh the value kept changing and it wasn't like the original numbers.
Yeah, absolutely. So in this case, it's the same way. X is not changing, Y is going to change. So if there's anything that gets passed in here, you kind of work backwards in the sense that, okay, let's say do it. You get to do it first here with A and B, right? So what is A and what is B?
I think it started off with 3, 4 at first.
Okay.
I
So I'll
kind
just
of, this is mostly my memory from what I remember the question asking.
Yeah, don't
That's
worry,
why,
you're
yeah.
good. You're good. Let's just use 3 and 6 as an example. That's totally fine. So whenever we have a function like this, it's a nested function. This doit is being used as a parameter of the outside doit. So let's work on the inside first. We pass in 3 and 6. 3 as x, 6 as y. So that means that b is going to be the one that gets changed permanently because that has the ampersand and it's being used as parameter y. So x is going to be, is that a plus sign here?
No, multiply.
Multiply. Okay, so x is going to be set to x multiply by x is, wait, plus equals 2. Okay, so that's going to be 3 times 2 is equal to 6. X is going to be set to 6. Y is going to be plus equals 2. So that means 6 plus 2 is 8. So y is going to be 8. We return x plus y. So that means in this position right here, it's going to be x plus y. 6 plus 8 is 14. So this is going to return a 14. When we do our parameter for the doit on the outside, we use the return type. So 14 will be on the outside, and C is over here as our second parameter. So it's going to be 14 and C. So let's just pretend that C is, I don't know. You know what? Let's actually use B as this case.
Okay.
That way it'll actually show us like kind of what's changing here. So I'm going to call the function again for 14 and B. Okay, cool. So we know originally x or A was 3 and y or B was 6. This 3 would not be changing. So if this had an A plugged into it instead of a B, I would be using 3.
Mm-hmm.
But because it's a B and that B was plugged in over here, something was changed to it. That 6 will become an 8 in the previous function, so we save that change. So we're going to be using 14 and 8 as our parameters. Again, if this was an A instead of a B, then I would just be using the original 3 there.
Mm-hmm.
But I'm going to use the 8 because that changed from the 6 to an 8. So if I do that one more time, I'm using 14 over here. I'm using 8 over here. So x is going to be set to x times equal 2. So that's 14 times 2. X is going to be 28. And then y is going to be plus equals 2. So again, y is 8. So y is going to be 8 plus 2 is 10. Return x plus y, 28 plus 10, that's 38. So this whole thing is going to output 38. Now the next line is saying C out A and then C out B. Okay, well, A never changed. It was always plugged in as the original value, 3. So A is still going to be 3. But B was changed twice. It was changed to 8 to the first time, and then it was changed to 10 as the second one, right? So
Mhm.
because we ran it twice, we're using 10 as that. Okay, I see a question in the chat. If a function parameter is just b without the ampersand, will changes to b inside the function affect the original variable? No. So if that ampersand was not there, we would still be using the original values of 3 and 6. The ampersand is the only reason that this y changed. If the ampersand was on this x instead, the x would be the one that would be changing. So this 3 would have changed to a 6 permanently. And then if we plugged it in again, it would be changed to whatever that would be. But we're only changing the variable permanently that has the ampersand. It's like it maps to the address to the original variable, and that's what changes it. I hope that makes sense.
And if both had the ampersand, then both would change, right?
Exactly, yes.
Okay.
So that's what's good to keep in mind with any of these questions. You want to just mark off where are things changing permanently and adjust the variables accordingly so you don't lose track.
Okay.
Great. Any other questions to keep for anything else? Kevin, do you have anything to add?
I think we went over everything. Actually, were recurrences and recursions, was that covered?
No, that's gonna be covered next week, I think. So it
Okay,
did seem
gotcha.
that, yeah.
Looking at Kathy's notes here.
Yeah, I took a look over here. It was pretty much just calling functions, writing functions, passed by reference, arrays, two-dimensional arrays, and arrays as function parameters. So I think we pretty much covered all of that.
Great. I mean, are there any other questions, any other things that we should go through? Just give you guys a minute to look through anything else.
I mean, I feel like we kind of went over everything, but if you guys want to do anything else, just let us know. Otherwise, we could end the session.
Yeah, we have until 6 o'clock.
Yeah.
Yeah, right now I've been spending my time debugging something. And
If that's it, I'm gonna send a little feedback form in the chat. If you could just answer that, we just would appreciate any feedback that you have. It helps us for any future sessions. So just if you could fill out the feedback form. Otherwise, best of luck with your exam. The best way, honestly, to study for that is just keep going through practice problems, and just try to like understand it. Try it with like those same problems, but with different numbers. And you could pass it through like a compiler and test it out for yourself. So like you could just kind of get the answers for yourself there, to check your work. So you don't have to like, worry, hey, is the answer right or not? So just try a bunch of different cases. But if you know those basics, if you could write the code and read the code, then you should be totally fine for the exam. So best of luck, guys.
Thank you so much.
You're welcome. Also, this session has been recorded, so it will be posted on the Learning Commons website as well if you want to refer to it.
Will it be posted like on Tuesday or something?
Usually it's posted as soon as it finishes processing, so
Oh,
probably
okay.
I'd say by the end of the weekend. Like, yeah,
Okay, thank you so much. Have a good day.
you too. Have a good day. Bye.
Bye-bye.